You know, what if one of the universe's biggest secrets isn't hiding in some far-off galaxy, but right here, in our own solar system, hiding in plain sight? Today, we're going to dive into a cosmic mystery that suggests a fundamental force of nature, one of the basic rules of the universe, might have been completely invisible to us this entire time. And it really all boils down to this one really simple but totally baffling question. Physicists are looking out at the cosmos, and they're finding that the rules that run the universe seem to be different way out there in the vastness of space than they are right here at home. How is that possible? So let's start our investigation. I want you to think of this whole thing as a kind of cosmic crime scene. When we look at the evidence from one part of the universe, it tells one story. But then when we look somewhere else, the story completely changes. The clues they just don't add up. And look, this isn't just some minor little inconsistency we're talking about. It's a huge puzzle that scientists have actually given a name, the Great Disconnect. It's this massive chasm in our understanding that separates the physics of the huge, large-scaled universe from the physics of our own local neighborhood. And here's where that disconnect gets really, really clear. On one hand, you look out at the cosmic scale, at distant galaxies, and we see the universe's expansion is actually speeding up, being pushed apart by some mysterious influence. But then, on the other hand, you look right here in our own solar system, and everything is, well, it's perfect. Everything is behaving exactly as it should. It's almost like the laws of physics are totally different in our own backyard. So how do we know something so strange is even happening? Well, let's follow that first trail of evidence, which is going to take us far, far beyond our own galaxy. Okay, so the main clue, the smoking gun, is that accelerating expansion. According to everything we know about gravity, the expansion should be slowing down, right? Not speeding up. So this points to something totally new. Now, the leading suspect for a long time has been this concept we call dark energy. But there's another, just as compelling possibility that there's a fifth fundamental force of nature at work, one we've never even accounted for. And finding a new force, that would be absolutely revolutionary. It would mean our most fundamental picture of the universe is incomplete. But every great mystery has a twist. And the twist here is a big one. When we look for this mysterious force in our own solar system, it seems to have a perfect alibi. It's just nowhere to be found. And that is the truly baffling part. For all the drama we see happening across billions of light years, when we zoom right back in on our own little planetary system, everything seems perfectly normal. The math all adds up, and that huge cosmic anomaly just vanishes. And the evidence for this normality is just overwhelming. I mean, the planets, they march along in their orbits with absolute clockwork precision. When we send signals from spacecraft past the sun, they bend exactly the way Einstein's theory of general relativity predicts they should. There are just no deviations, none. It's as if this powerful cosmic force just stops at our front door. So this leads scientists to this incredible idea. What if the force isn't missing at all? What if it's just hiding? So let's investigate the two prime suspects for how a fundamental force of nature could be playing a game of cosmic hide-and-seek. The key idea behind this whole cosmic disappearing act is something called screening. The general thought is that maybe this fifth force is, well, maybe it's a little shy. It behaves one way out in the vast, empty deserts of space, but it totally changes its behavior, or maybe it gets suppressed, when it's in a crowded, dense environment like our solar system. Okay, so we have two main theories for how this screening thing works. Suspect number one is the chameleon model. And yeah, just like its name suggests, this theory says the force itself literally changes its properties. It's strong and super influential out in the low-density vacuum of space, but in a matter-rich area, it becomes so unbelievably weak that our instruments just can't see it. Then you got suspect number two, the Weinstein model. In this one, the force's strength is always constant, but the powerful gravity of something like our sun creates this suppression field all around it, basically cloaking the force's effects from us. And this is where that Weinstein model gets truly mind-bending. The estimated size of the sun's suppression field, what they call its Weinstein radius, is a staggering 400 light-years. To put that in perspective, that's not just to the edge of our solar system, that's an enormous bubble extending way out past many of our neighboring stars. So here's the really crucial point. This theory doesn't just explain why we don't see the force right here. It explains why it might be hidden across a vast section of our local galactic neighborhood. It's literally hiding in plain sight on an absolutely epic scale. Okay, so these are absolutely fascinating theories, but how do we get from theory to fact, right? How do we actually crack this case? Let's talk about the game plan for actually hunting this hidden force down. And this brilliant insight really comes from NASA physicist Slava Tourashev. He points out that simply building more and more sensitive instruments to look for tiny anomalies in our solar system, well, that's probably a dead end. We've already confirmed standard gravity countless times. To find something new, we need to know exactly what tiny, specific effect we are looking for. So the path forward is actually a really clear three-step process. First, you analyze all this data from big cosmic surveys to build a really precise hypothesis about how this fifth force might behave. Second, you use that hypothesis to make a specific testable prediction. And then, and only then, third, you design a mission with the single purpose of confirming or denying that one prediction. So the ultimate takeaway here is this. The challenge isn't just a technological one. We don't just need a better ruler. We first need a brilliant, testable idea that tells us exactly where we should be measuring and what we should be looking for. The idea, the theory, has to lead the experiment. Which, it leaves us with this final, really fascinating question to think about. If a fundamental force of the universe, one of the basic rules of reality, can hide from us so well, right inside a bubble of our own making, well, what else might be out there, operating just beyond the edge of what we can see, just waiting for the right idea to finally bring it into the light?